Here's the deep problem of free will. On the one hand, our human sense is that our actions are fully free. On the other hand, our scientific sense is that every action is determined by a prior action. What is free will? Do we have free will? That's the big question. Free will is such a big question that the John Templeton Foundation has funded a multi-year study with experts in science, philosophy, and theology. The project is called Big Questions in Free Will. It has 60 participants, 4 conferences, numerous experiments and papers, all to research, test, discuss, and debate free will. I'm Robert Lawrence Kuhn, and Closer to Truth follows the project, asking the big questions in free will.
I've been interested in the strength of individual decisions. So if I choose to do something, can I do it really strongly or kind of just decide to do it? Do decisions come by degrees, or are they a simple binary yes, no kind of thing? Hi, Jennifer, how was that?
Patrick shows me one of his experiments in which he measures the brain activity of a subject when she makes a simple choice: to push a button with her right hand or her left hand.
Now we're going to ask you to develop an intention to go left or go right, and then suddenly switch it to go right or to go left. So we're going to give you the arrow in the center of the circle right at the start, which explains the intention we want you to have. And then as the yellow circle rotates on the screen, it'll give a little, very brief green flash. And that's a signal to you that you have to switch your intention to make the other action. Think left, switch. Good. Think right, switch. Good. And then we're just going to leave you to get on with it, and we'll be back in about 5 minutes. Is that all right?
Yep.
Thanks very much. So,
Go for it.
here we go.
Patrick shows me the results of his experiment. Initially, he ran a test in which he asked the subjects to choose simply right or left. In charting the brain activity, he uses a green line to represent the intention to go right and a red line to go left. When mid-trial, he then asked the subjects to change their minds, he noticed an interesting change in brain activity.
So what we've shown here is a clear change in the position of the green and red trace on the y-axis at the point where the circle gave a little flash telling her to switch. What we can see is when she was originally intending to press with her right hand and was asked to switch, then this trace goes down and we can see it crosses over the trace that corresponds to intending to press with the left hand and switching to the right. We're trying to work out not only when intentions develop, but how they evolve over time, and in particularly how rapidly they can be switched, because it's very common that you develop an intention and then you might change your mind. Perhaps you change your mind at the last moment, and actually perhaps that's really useful. So it might well be that one feels like punching somebody in the face. That's not very good, but what's really bad is if you actually do it. So the ability to change an intention or switch an intention or suspend it is probably extremely important in terms of self-control. And in the long run, I think there's a very strong relation between the neuroscience of free will and the way that we control our behavior as social animals.
It does wake up where you see your whole life, but no, we don't. But the question is when you have
Christof, your experiment involves real-time work with patients who have electrodes implanted for medical reasons. What is the basic science, the basic neurobiology behind the experiment?
Our experiment are basic variant of a famous experiment by Benjamin Libet. We're trying to understand the neuronal mechanism that underlie a voluntary decision that traditionally people would say involves free will. And we know from previous experiments there are several components to this. One component relates to this feeling that psychologists now call authorship or agency. I lift my right hand, and I have a feeling that I, not you, not my parents, not my friends, were responsible for me lifting this hand. We know there's a specific locus in the brain that generates this conscious sensation. We like to separate that out from the neural mechanism that actually give rise to what I personally feel is this voluntary action. What are the actual mechanisms? Where's the decision first taken, and what parts of the brain are involved in what sequence? So finally, I lift my right hand. And more interesting from a practical perspective, can I predict this ahead of time? Can I maybe read off your brain signal so I can know 1 second ahead of time, are you going to move the right hand? Are you going to move the left hand? The other thing we're interested in is choices that involve deliberations, because that also brings in moral judgment. Should I be doing this? Is this a wise idea? Am I going to hurt somebody, etc.? And so there we're devising a slightly different paradigm where we play a simple game where the patient is free to move one or the other hand. At some command, we lift both of our hands. However, if you lift the same hand as I do, then you win $1.
Right.
And if we do this, you see, then I win $1. And once again, this is much closer to the real decision that we care about, because it has consequences and you deliberate rather than just, it doesn't matter, I pick this or this, they're exactly identical. I can take out both, so I have to take one. Now the neural mechanism is the same.
Christof sends me to Cedars-Sinai Medical Center in West Los Angeles. I'll have a ringside seat watching the brain make real-world decisions. A patient has graciously allowed me to observe as she undergoes brain surgery for epilepsy, and then afterwards as she participates in experiments of decision-making and free will. I meet the neurosurgeon, Dr. Adam Mamelek.
We do an operation, a craniotomy, where we open the skull and put a sheet of electrodes on the surface of the brain. It covers the area that we think is involved, plus the periphery around it.
Dr. Mamelek introduces his patient, Audrey.
Hi,
Hello,
nice to meet you.
pleased to meet you.
Every week of her life, since she was a baby, Audrey has endured multiple epileptic seizures. Now she can be cured.
We'll be able to record your seizures, but we'll also be able to map the different areas of brain function.
Okay.
And we can also do other tests to really try to understand not specifically how your brain works, but how the brain works in general.
Okay.
And one of the questions that we're very interested in studying is, how do you make conscious decisions?
Yeah, appreciate it.
It's a remarkable procedure. By charting Audrey's brainwaves, neurosurgeons create a fine-grained map of her brain, enabling them to locate and remove the lesion that causes her seizures. At the same time, neuroscientists can examine brain activity during decision-making, seeking brain-based facts about free will. A week later at Caltech, Christof's partner, neuroscientist Uri Maus, shows me the results.
Basically, the patient and I are playing a simple version of the rock, scissors, paper that children play. If I raise the mirror image of what you raised, then let's say I win.
Okay.
And if we raise the same hand, so if you raise your right hand and I raise the right hand, then you win. We start with $5, and every time she wins, I give her 10 cents, so I lose 10 cents and she gains 10 cents. And if she loses, it's the other way around. And if she doesn't react quickly enough, because the idea, of course, you can always just wait to see what the other guy is doing
That's
and move,
cheating, yeah.
we just deduct 10 cents. So it becomes competitive. We play for about 50 rounds. What we're interested in is finding the difference between preparatory activity towards moving the left hand versus moving the right hand, to be able to predict which hand you will raise before the go signal telling you to raise your hand is even there. So we have this grid here, which is much closer to the source of the signal than you would have if it was EEG and it's sitting here and there's the tissue and the skull and everything, the attenuation of the signal, and you don't know where it's coming from. So here we're much closer to the signal. So this grid is in her head here, and from this grid we see these wires coming out. From here it goes into these panels here, and from there there's a wire that goes to a system that records and does some analysis, and from that system through another wire that you kind of maybe see here, goes into this machine, and I get a beep either on the right ear or on the left ear, which tells me to raise my right hand or my left hand in order to beat the patient. And this is half a second before the go signal. So I know what I need to move, and I just wait half a second for the go signal and move it.
Okay, let's see what really happened.
Okay. This is counting down 5, 4, 3, 2, 1, and then go, 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 and we raise our hand. So if I win, my side of the response box lights up in blue, and if she wins, her side of the response box lights in red. 5, 4, 3, 2, 1, go, and this time I win. And then we try it again, and so this goes on like that for about 50 trials. There's a screen behind Audrey. She can't see it, and the screen shows an arrow which hand she's going to raise according to the real-time system. So she's about to raise her right hand, and
the arrow comes on like just a fraction of a second before she moves.
Right, before the go signal.
Right.
So this time she did raise the hand that the arrow was pointing at, and again it was correct. She raised the hand the arrow was pointing at. So we were able to beat her, and we played 3 times. I was able to win with a relatively large margin 2 of those 3 times. She was competitive about it. It had meaning.
Yeah,
that was the important thing for us.
Okay, so what are the implications for free will here?
Well, if I can predict what you're doing when your decision is making a difference, it might be stronger evidence that these unconscious processes are affecting also these types of decisions that are more important for moral responsibility.
Now, the implications of what you're saying, though, is that if you are able to predict this to the degree of accuracy that you can, our brain is making our decisions and we're not. It does give us some philosophical pause about what free will is. That's very good.
My goal as a research psychologist is to figure out what happens inside the mind and so forth that produces the behavior. I got into studying free will by virtue of my research on self-control. Self-control is difficult, so it depletes some energy, and after that you're not as good at self-control until you replenish. When we found that the same energy is also used for decision-making and initiative, and I said, okay, well, this is bigger than self-control, that's when we started talking about free will. Common theme.
Roy is conducting 2 kinds of experiments on free will. The first examines beliefs about free will and how they can change.
Robert, this is Michael Ent. He's a PhD student in our laboratory.
Looking forward to the experiment.
Okay. Yes. This was all his idea. He came up with the idea that we could manipulate people's beliefs about free will by manipulating their body's states.
Okay, so there's 2 conditions. Participants in one condition, they demonstrate a voluntary response. So they bounce the ball in one hand and catch it in the other.
They get the feeling of deliberately, consciously controlling their bodies, and that should increase their belief in free will because it calls attention to how they mentally control their actions.
And then participants in the other condition, they have their involuntary reflexes triggered. So I blow a puff of air into their eyes, and then I shine a light to, stimulate their pupillary reflexes.
Right. That's not something you use free will for. It's an automatic response. That should kind of cue you into the idea that your body works like a robot and that you don't have free will.
Okay, so now I'm just going to have you complete this questionnaire about your beliefs and attitudes, and I'll come back in.
Roy's theory proves to be correct. Subjects who perform voluntary actions report a stronger belief in free will, while subjects whose involuntary reflexes were triggered report a weaker belief.
The important idea here is that beliefs about free will are flexible, are malleable, subject to cues even coming inside ourselves. And perhaps we shouldn't be surprised that the philosophers who've been debating this for centuries haven't reached a decision yet, because even each person's own beliefs might change. So, what we might think of as a medical, physical opinion in this very abstract way is in fact something that's influenced by cues coming from inside our bodies, and it can go up or down.
Next, Roy investigates the individual psychology of free will, asking whether our capacity to exercise free will can change. In Roy's theory, making free will decisions takes energy, and since bodily energy is finite, The more decisions we make, the less free will we have. Roy and his assistant show me the experiment.
First, we have people make a variety of decisions. This first task is a choice task. So there's a variety of products on the screen, and I'll ask you to make choices between the two products, one on each side. And then we bring them over to the ice bath, and we put their hand in the ice water and see how long they can take it. Both how long they wait until they can actually feel pain, and then also how long they can last total. When you feel pain at first, say now, and when you can't bear the pain any longer, remove your hand and say stop.
Now.
All right.
To determine how prior choices affect subjects' willpower, Roy repeats this experiment, but with one crucial difference. Subjects view the same products, but now do not choose between them. This is the control.
People in the control condition tend to last about a minute on average. And after making choices, they only last about 45 seconds.
That's a big difference if you think about it.
It is.
So willpower is like a kind of muscle, exhausted by repetition. The more we use it, the harder to continue to use it.
Yes.
This means that free will has biological constraints. Is this a new kind of free will?
Philosophers have been debating for centuries, yes or no. Do people have free will or not? We should stop trying to give a yes or no answer to what people say free will and instead say, how hard is it or how much does it take for this person to exert free action? What are the things that will make free action easier? What are the things that will impede free action? All right, that's it.
For Roy, psychology shows the working complexity of free will, how we view it, how we exercise it, and what our capacity is for free action.
Because people have found that under hypnosis, you don't get the synchronous gamma associations that have sometimes. So you seem to be really.
Now, you have a research project, part of this big Questions in Free Will project, that is going to use hypnosis?
That's right.
How's that going to work?
Well, hypnosis is an excellent tool that is just really coming into its own in cognitive neuroscience. I think for a long time, it's got this sort of checkered history of being part of a stage show, circus act, black magic, and so science wasn't going to touch it with a 10-foot pole. And then with the advent of neuroimaging, we started to see, oh, this is a real thing. It's an altered state of consciousness. It's something that's happening in the brain that we can study scientifically and utilize, exploit. Because what is great about hypnosis is that you can hypnotize someone to do a behavior that would just unfold as it would normally, but they lack agency for that behavior. So they're creating it, but they don't have the feeling of authorship of that action. And we're really interested in what's that authorship feeling doing, if anything.
Which is free will.
Which is free will. So the basic idea with what we want to do is use hypnosis to take away this conscious awareness that you're about to move and see, do you still move if you don't know you're about to do it? And does the neural activity look the same? If nothing changes, then it suggests that becoming aware that you're about to move isn't really instrumental to your movement. If we show the opposite, that it does change things, we don't really get the movement, or the neural activity looks completely different, then it is doing something, and we need to take that into account, and maybe I need to revise my strong stance.
That free will is an illusion.
Yeah, maybe, yeah.
Talia takes me to watch her experiment.
Here. So I want you to just relax as much as possible. Get yourself in a comfortable position. Take a few deep breaths.
Once the subject is hypnotized, Talia instructs her to perform actions that will be triggered after she wakes up, but without the conscious feeling that she is willing those actions herself.
A little later, you will watch some video clips. Each video clip will have a red arrow next to it. If the red arrow is on the right side of the video, you will squeeze the ball in your right hand.
She will watch a screen and squeeze a ball when she sees an arrow. She will assume that this is an involuntary action when in fact it was implanted by the hypnosis.
Remember, you'll remember nothing of what has happened until I say to you, Now you can remember everything. 3, 2, 1. Wide awake. All right, let yourself wake up.
So what was the last thing you remembered before you woke up?
Sitting in the chair and, yeah, nothing else besides that.
Let's go do the experiment.
Okay.
Now, as in the Libet experiment, the subject is fitted with electrodes on her scalp and arms to measure electrical impulses in her brain and muscle movements in her arms.
Like a Christmas tree.
But this time, the subject is told that the electrodes on her arms will stimulate her muscles. So she will believe that her arm movements, which are really triggered by hypnotic suggestion, are not voluntary, not affected by her conscious thoughts.
You're going to be just viewing some short nature videos. They'll be about 20 seconds each, and then there'll be a little pause.
Talia's research assistant shows me the real-time results.
So in each video clip of 20 seconds, there would be one
squeeze. So see, she just squeezed with her left arm. So that's what a squeeze of the stress ball, that's what we want to see. So there she just moved her right arm off, and so that's the muscle potential from her right arm. So what we'll be looking at is the data leading up right to that squeeze.
Later, Talia brings the subject out of hypnosis.
Now you can remember everything. Now you can remember everything. So it felt a bit...
Then they reattach the electrodes and ask the subject to contract her arm muscles voluntarily to see if there is any difference when conscious decision-making enters the process. After the experiment, I meet with Talia and her partner in the project, neuroscientist Peter to discuss and debate the results.
So this is Kaylee.
That's Kaylee's data.
What are we looking at?
Well, 0 is when she made a squeeze.
Right.
And the red line is when she made a squeeze due to the post-hypnotic suggestion. And the blue line is when she made a squeeze because she decided consciously to do so. And you can see that the lines are largely overlapping.
And so what's the significance of that?
Well, it shows that motor action and the accompanying readiness potentials don't require the sort of feeling of authorship, of agency of your action. They unfold naturally with or without it.
And how does that comport with each of your views of the nature of free will?
We've been doing this out for 7 years, so it's an old
We
debate.
disagree.
Yeah.
I think that it's a problem for the sense that we have that at any moment we could decide to do otherwise, that this conscious feeling of being sort of free agents making decisions, this is, I think, a problem for that view.
Peter, you disagree with that, I think.
Well, I mean, I think that I don't think we have, proven that consciousness plays no role. We've shown that consciousness is not necessary for making a volitional or endogenous motor act. But that is not where free will lies. It lies in this totally different domain where you're trying to decide who to marry. You're trying to decide whether to learn Spanish or...
Although the question is, why do we have a feeling... I agree with you that this is relatively meaningless, but we still have a sense of when we decided to do it. Why do we have it?
So for something to be causal, it has to be indicative of the future, a future event. Something going on now causes something in the future. But these kinds of judgments that we're talking about, that I did it, are about what just happened.
Or I've decided to do it.
Yes, but these are retrospective. They're due to a comparison of what's intended or planned and what is actually being executed. Talia and I, we've had these debates for 7 years now. Ever since she came to Dartmouth, we've been duking it out.
I think actually we agree. We don't agree on the definition of the term free will. That's where the disagreement
Okay. What does free will mean?
I think it means that I could choose otherwise in the moment.
Right, and I think it means that you can choose otherwise in the future. The system can make choices now that will have an influence on what will happen in the future.
But is that a fundamental difference?
Yes, it's a difference in kind, not just degree.
What do you think?
I think that, the jury's out. We just don't know. I don't think that there's a different kind of neural causality that plays out.
The fact that we found an example where consciousness appears not to play a role in subsequent acts doesn't mean that consciousness does not play a role in all subsequent acts.
No, granted, but it does demonstrate it here.
Sure.
Thank you for watching. If you like this video, please like and comment below. You can support Closer to Truth by subscribing.